Lesson 2 of slope, we're basically just taking slope to the next level. Now, a quick review. Remember, we like to work left to right, so when a line goes up to the right, it's going to be a positive slope. So both numbers are going to be positive in my rise or run or my fraction. So this one could look like 3 over 5. Now, if you get an answer like -3 over -5, that's okay. But remember your integer rules. A negative over a negative, or the same thing as a negative divided by a negative, that's going to be a positive. So -3 over -5 is the same thing as a +3 over +5. Both of these will result in a positive slope. Our next one over here, left to right, if it's going down, this is a negative slope. That means only one of your numbers, the numerator or denominator, will be negative. So this one could look like -4 over 3 or +4 over -3. You get the same thing if you divide those out. When you have one negative, one positive, this will result in a negative slope. Now we have a horizontal line and a vertical line. Remember, if you're doing a horizontal line, it doesn't go any up or down. If it doesn't vary at all up or down, that is a zero slope. It is not steep at all. It's zero slope, or also known as no slope. Remember, way to remember this. If Teddy goes for a ride on this slope, he's going to have zero fun because he's not really going anywhere. Over here, different story. If I were to give Teddy a push off this, he's definitely going somewhere. An undefined slope is a vertical line. Remember, if Teddy goes for a ride there, he might just do that. But more of a way to think about it, but if you remember it that way, so be it. Vertical line is undefined. It'll never cross the y-axis. All right, looking up here. All we need are 2 points to find the slope of a line. Now, you got to pick 2 points that go directly through an intersection. This one's close, but it's not exactly through it. This one's also close, doesn't work. This one's not close at all. So the ones that go perfectly through it are this one and this one. I'll go ahead and draw my right triangle straight down, straight to the right. What's my rise? Goes down 1, 2, 3, 4, 5, 6, 7, 8. If it goes down 8, my rise is -8. Over represents the fraction bar, and it goes over 1, 2, 3. Now, when you look at that slope, can that be simplified? No. So that is your simple answer right there. Your slope is -8 over 3 or -8/3. Now, you can go in the other direction, like I was saying. You can go up 8, left 3, which can be written 8 over, and if you go left 3 on a number line, that's 8 over -3. Those are both the same thing, but usually it's going to look like negative off to the side, and then your 8/3 right there. Now, let's look at one that can be simplified. I'm going to pick this point and this point down there. After you draw your triangle, we go down 8 over 2. If I go down 8, that's -8 over a +2. Now you'll tell yourself that can't be simplified. What goes in both -8 and 2? You'll say 2, you divide them out, divide them both by 2, we get -4 over 1. That means if it can be simplified, there's going to be another point on this line between these two. That means I can also go, if I can go down 8 over 2, I can also go down 4 over 1. Let's try it. 1, 2, 3, 4. 1 over, and there's the other point on that line. Now, when we work in the opposite direction, look at these 2 points. Remember, all you need is 2 points. Let's look at rise over run. We go up 2 over 2. If your slope is 2 over 2, you know that this reduces to 1 over 1. That means every time we go up 1 over 1, up 1, right 1, up 1, right 1, there's going to be a point. Up 1, right 1, up 1, right 1. It kind of forms a perfect staircase. Now, if you run out of room, you can also work in the opposite direction. You just take the opposite sign. So instead of going up 1, we go down 1. Instead of going right 1, we can go left 1. Same thing. Down 1, left 1. Down 1, left 1. If you connect all these dots, they all lie on the same line. So don't forget, if you run out of space going one direction, just go in the opposite way. Just take the opposite values. Now, this is the extra step we're looking at today. We look at rise over run. Remember, y's are your y's. Rise is the y-axis. You got to figure out what's the value of each axis increment. The value of each increment, I should say. So if every 2 lines go up 100, that means every line goes up 50. Up 50, so 100 would be 150, 250, 300, 350, so on and so forth. Down here, every 2 is going by 2. That means each line is just counted by 1. So 1, 2, 3, 4, 5, 6, 7, 8, so on and so forth. Now that you know the values, now you can do the rise over run. So I'm going to pick this point right here and start off easy, that point right there. From 50 to 100, you might want to say we just went up 1. Well, technically we went up 1 little box, but what was the value of that box? From 50 to 100, we went up 50. Now from 0 to 1, we just ran 1 unit. So our slope is actually a slope of 50. Now it doesn't matter which 2 points you choose, that will stay consistent. So let's say we choose 150 and 2, and 250 and 4. From 150 to 250, we went up 100. And from 2 to 4, we ran 2 units. And 100 over 2, you know, simplifies to 50 over 1, or just 50. The exact same thing. Now, working in the other direction too. This could be an example like if we're dealing with a plane. The plane is descending. We know that descending is a key word to know that we are dealing with a negative slope. But first we have to figure out what are our increments. So every 2 is counting by 4 thousandths. That means each increment is worth 2,000. So this would be 6,000, 8,000, 10,000, 12,000, 14,000, and the last one would be 18,000. What is our x-axis counting by? Well, every 3 lines is going by 3, so we know it's also going by once again 1, 2, 3, 4, 5, 6, 7, 8, 9. Now that we know our values, we can do our rise over run. Now remember, it's got to be a negative slope. We can tell that from the picture. Now just pick up 2 points. So I'm going to do right there 18,000 and 0 and 16,002. So rise first. From 18,000 to 16,000, we went down 2,000. So down 2,000, the same thing as negative 2,000 over, and we were counting by 1, so we went down 2,000 over 1, 2. So negative 2,000 over 2, can we simplify that? Yes, we can. Divide them both by 2, and we get negative 1,000 over 1, or just a slope of negative 1,000. Doesn't matter which points you choose, you divide them out, you simplify them, you get the same answer for a slope. Now, on your own, there's our 2 to try on your own. Go ahead and pause the video and I'll scoot up the camera so you can see them better. Alright, let's go over these. Hopefully you pause them and try them on your own. This first one, you know it's going to be a positive slope. Now I got to figure out what are the increments. Now every 3 it goes up 30. So every 3 it goes up 30. I know I'm counting by tens. 10, 20, 30, 40, 50, 60, 70, 80, 90. What do we count by over here? Well, every 2 are by 5. So that's kind of confusing. That's actually counting by 2.5. So this would be 7.5, 12.5. I'm just going to deal with the 5, 10, 15, 20 to make it easier on ourselves. So pick those 2 points. Let's use 30, and the 5 is at 50. So our rise from 30 to 50, we went up 20. So our rise is 20 over, now since it's going from here to here, we ran 5, that's 20 over 5, which reduces to 4 over 1, or your slope is just 4. So for the first one, I'm starting to stutter. A slope of 4 is the correct answer. Down here, you know it's a negative slope. Pick out 2 that work for you. Perfect intersection, right there and right there. Remember, I like to use the 2 that are closest, so it's less counting. From this point to this point, down 3 over 1. We go down 3, that's negative 3 over 1. We get negative 3 over 1, or just a slope of negative 3. That means every time I go down 3 over 1, there should be a point. Let's check it. Down 3 over 1, there's a point. Down 3 over 1, there's a point. Or we go in the other direction, we go up 3, left 1, 1, 2, 3, 1, 1, 2, 3, 1. So this lesson, just make sure you are looking at the values of the increments of both the y-axis and the x-axis before you calculate your rise over run. Thank you.